when the bodies are hanging vertically over the pulley. The direction of motion is given. It moves upward from here, downward from here. Okay, the direction of motion is usually given in the question one way or the other. Let me draw or let me convert this one into free body diagram. I'm going to change the value of the masses. Instead of small n and capital M, I'm going to call it M1, and the second one I'm going to call M2. I have to label the forces. The direction of the tension would be upward here and upward here, because tension on both sides would try to stretch the string. Sorry, the weight on both sides would try to stretch the string, but the tension would try to compress it or bring it back. The weight due to the mass M1, we call it W1. The weight due to the mass M2, we call it W2. And what else do we have? Yeah, that's pretty much it. The direction of acceleration is upwards from the left side and downward from the right side. How do we know? From the given direction of motion. Pulley is rotating clockwise. Okay, let me call the object on the left as the object A and the object on the right as the object B. Both sides are now accelerating. So we have to write equations for both of them. Let me write the equation for A. We start off with the Newton's law, which is F resultant equals to ma. So ma as it is on the right side. But what is the resultant force on the side A? So we have T minus W1 because the object is moving upwards. The acceleration is upward. So T has to be greater than the force downward, W1. So the resultant force would be T minus W1. Or you can also write it this way, T minus W equals to mg. So I can write it this one as mg. And the mass on the left side is m1. So all the masses would be written as m1. But we don't need to write g1 because acceleration of free fall or gravitation field strength is same for both of them. So no need for the subscript with g, and also no need for the subscript for tension, because the two objects are connected with a single string, so the tension in the string would be same. For a single string, you can never have two values of tension, two different values of tension. For a single string, you have only one value of tension. So we don't need to add the subscript. Now for the body B. Let's go with the same way. F resultant equals ma. In this case, mass would be m2a as it is, but what is the resultant force for the object B? The object B is moving downward, so the downward force has to be greater, and the resultant force would be downward force minus the upward force, which we can also then write it as, instead of W, we can write it as m2g, because W equals to mg, minus T equals to m2a. How many? So you have two equations. What usually happens is they ask you to find the value of t as well as the value of a. The most important thing is whenever the system is accelerating, forget about all the types. If the system is accelerating, you have to start off with the question from this equation: F resultant equals to ma. Whenever there is acceleration, you'll have to use this one, this expression. Now you can say for this question we have two sides. We have the side A and we have the side B, just for the sake of convenience. Now you can use this equation for the body A, and then you can use the very same equation or expression for the body B. Won't make any of the difference. You just use it as it is. So for the body A and for the body B, we're going to use F resultant equals to ma. Now before you could use that, let me label some of the forces over here. So the mass on the left side is m1. Due to that mass, the weight would be vertically downward, first of all, and the weight would be mass times gravitational field strength. And likewise, the weight of the small mass would be same, would be done by the same method. So vertically downward, and the weight would be mass times gravitational field strength. Mass times gravitational field strength for the other one also. And as the mass is hanging from the string, forget about any motion. If the mass is hanging from the string, the weight of this mass, or due to this mass, the string is being extended, hence the tension would be against that force. So the tension would be upwards. As I explained in the topic of tension, since you have a single string, for a single string which is not even broken into pieces, for a single string you must be having a single value of tension. You cannot have two tensions, two values of tension for a single string. So that's why I don't need to write subscript with the tension. I don't need to write T1 or T2. Now, what do we need to find? We need to find the acceleration of the two blocks. So they have same acceleration in magnitude, but the only difference is one of the acceleration is if downward, then the acceleration of the other one is upward. So if this one you call downward negative, let's say this is the convention you use, then the other one has to be plus 3 ms minus 2 meter per second square, but magnitude wise it is same. This one is also 3 and the other one is also 3. Magnitude wise these two would be same. So let me apply F resultant equals to ma on the left side, on the body A. So for the body A, we have two forces, the ones I have highlighted over here. Which one of these two forces is greater? The answer is the one in the direction of the acceleration. So the resultant force would be bigger force minus the smaller force, and that equals to ma. What is the mass of the object A? Capital M. So that's it. This is the first expression that we have. Let's move on to the right side. which is the object B. That is also accelerating. So I have to start from F resultant equals to ma. But then the thing is, what is the resultant force on the right side? Is it T minus mg or mg minus T? Well, it depends on the direction of the acceleration. Since acceleration is upward, it means the upward force is greater, so it should be T minus mg. And that equals to ma, because the mass on the right side is small m. So we got to write it as it is. Now, in the next step, you need to find the formula of acceleration, and they have in all the options T is not there, so they have eliminated T. The tension has been eliminated. So you call the first one, let's say this is the first equation and this is the second equation. What you can do is, it's only your choice if you want to substitute the value of T from one equation into the other one, or if you want to eliminate T. I'll personally, at least for this one, I'll go with the method of elimination. So I'll write the first equation first. Underneath that, I'll write the second equation, but I'll write the second equation like this. I write the like terms in front of each other, but the equation is same. Then I can draw a line in the middle, and you see one thing. Plus T minus T can be cancelled out, like this. And what do you get on the left side? You get m g minus small m g. And on the right side, you get capital M A plus small m A. This is what you get on the right side. Since you need to find the expression for A, what I can do is I can take A common on the right side. So if I take A common on the right side, I'll be left with capital M plus small m. And on the left side, since they have taken G common in all the options, I can also take G common. So if I take G common on the left side, I'll be left with this thing. Now this expression is being multiplied by A, and so on the other side, it should be divided. So this is the expression that you should have for the acceleration. If you want to memorize it, you're very welcome. In some of the questions, you can easily find if they ask you to find acceleration and you have memorized this expression already, provided it is the same type. When two objects are hanging vertically, connected by the pulley, and they ask you to find acceleration, you can easily apply this expression, which is the difference of the masses divided by the sum of the masses times the value of G.